Welcome to Get Your FRQ On. This question is from 2026. It is question 4, and it is not calculator active. In the question stem, we have a twice differentiable function f defined on the closed interval from -4 to 4. We are given that f of 2 is equal to 3, and we are also given the graph of f prime, the derivative of f. In part A of this question, for x greater than 0, the function g is defined as f of x minus the natural log of x. We are asked to find g prime of 2 and show our work doing so. Now, based on the definition of g prime of x would be f prime of x minus 1 over x, which means that g prime of 2 would be f prime of 2 minus 1 half. Now, because we have the graph of f prime, we can use the graph of f prime to determine f prime of 2. It turns out f prime of 2 is 1.5. So we get g prime of 2 is 1.5 minus 0.5, which is just 1. So g prime of 2 is equal to 1. In part B of this question, we are asked to find all values of x on the open interval from 0 to 3, where f of x has a point of inflection, and to give a reason for our answer. So we know that the graph of f would have a point of inflection whenever f prime of x changes between increasing and decreasing in either order. And based on the graph of f prime of x provided to us, there is only one value of x on the interval from 0 to 3 where f prime of x changes between increasing and decreasing, and that is at x equals 1. In part C of this question, we are to consider the closed interval from -4 to 4 and determine where f of x is both increasing and concave down, and to provide a reason for our answer. So the graph of f will be increasing and concave down whenever f prime of x is greater than 0 and is also itself decreasing. Based on the graph of f prime of x provided, these two criteria are met simultaneously only on the closed interval from 1 to 3. For part D of this question, we are again considering the closed interval from -4 to 4. We are asked to identify any x at which the function f of x has an absolute minimum and the x where f of x has an absolute maximum. So we'll start with the absolute minimum. F will have an absolute minimum either at -4, +4, or some value of c in between them, such that f prime of c is equal to 0 and f prime of c changes from negative to positive. Based on the graph of f prime of x provided, f could have an absolute minimum at either x equals -4, -2, or +4. Moving on to the absolute maximum. The graph of f will have an absolute maximum either at -4, +4, or some value of c in between them, such that f prime of c is equal to 0, and f prime of x changes from positive to negative. Based on the graph of f prime provided, f of x could have an absolute minimum only at -4 or +4. Now, to figure out where the absolute maximums and minimums actually occur, we're going to compare some definite integrals. The integral from -4 to -2 of f prime of x dx is negative. The entire region is underneath the x-axis. This implies that f of -2 must be less than f of -4, even though we don't actually know what those values are. And the integral from -2 to +4 of f prime of x dx is positive, which implies that f of -2 is less than f of 4. So because Those are the only three candidates. That's what we need to consider. If we look at the absolute value of those two integrals, we can see that the absolute value of the integral from -4 to -2 of f prime of x dx is going to be less than the absolute value of the integral from -2 to +4 of f prime of x dx, which implies that f of -4 is going to be less than f of 4. So based on all of this, the graph of f is going to have its absolute minimum value at x equals -2 and its absolute maximum value at x equals 4. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.